Well, Casey, thank you for helping my project. Could you say a little bit about yourself?
Yeah. Um, in case it's not clear, I'm really into space, and I'm I work for a defense contractor tracking space objects as a day job. I fly for the Air Force Reserve as my other job, and I'm prolifically involved in a lot of grassroots space projects, from payload development to public outreach and everything in between.
That's amazing. But first, starting with your shirt, today was a big day for the first captain.
It was, it really was. And I'm surprisingly, even given his sort of reticence in the past to be kind of like embrace that public image, he was pretty eloquent following the flight. And I was impressed by everyone kind of picking up on that and kind of just distancing themselves from the PR hoopla that kind of comes with these flights right now.
I caught a few of the pre-flight interviews he did on some TV shows, and he was a little bit uh, trying to be funny, but it came off a little bit snarky, maybe.
I think that a lot of his interviews have a tinge of cynicism to them.
And then afterwards, he was like saying it's almost undescribable, and started talking about how Jeff said the same thing and how they need to work on describing it. And then he started like really getting into it, and was basically moved to tears by the time he kind of got into it.
Yeah, I really think that that's going to do a great deal for the not just this idea of suborbital space flights that you can pay for, but the idea that there's something to be said for bringing somebody that can speak to those things. And I was just looking on Twitter at some of the more prolific engineers who work at some of the NASA labs talk about how, as much as they appreciate the nuts and bolts and the algorithm that creates all this and makes it possible, maybe they recognize that maybe they aren't the best speakers for this, and finding somebody that can kind of illustrate better the experience can go a long way for the industry.
I just maybe this is having to do with age or cynicism or something like that, but I mean, William Shatner is an actor. He's like meant to play a part to meet the director's expectations, right? And uh, how much? I mean, is it's just me thinking horrible thoughts, or does that cross other people's minds
No,
too?
I don't think you're the first person to point out, like, well, he is an actor. Given the more over dramatized acting that he's particularly famous for, and the stilted speech, this seems fairly genuine. I want to believe in what he said.
Of course, when you put on and take off people all day long, it's very easy to forget who you are.
That's true.
So I was wondering, I'm looking forward to sending like a poet or a artist or a musician, somebody that actually does that creation part of the creative stuff. That should be really interesting.
I could, with the proliferation of the vehicles, the access, I can't see how that won't happen soon, to be honest. I think that at this point, it's more than inevitable.
And I had a question about your pilot experience. Did you start out on small planes like Cessnas, or did you go straight into the Air Force and start out with jets?
It's a little bit of both. My timeline was kind of compressed in that years. I did a little bit of like familiarization with flight training while I was in college, but I wasn't really, how should we put it, affluent enough to cover it. So I did what I could to familiarize myself, competed through Air Force ROTC to get a flying slot. The Air Force made me a navigator, and I have flown backseat in high performance vehicles for almost 20 years since, which I have since capitalized to sort of sell myself a bit as like a mission specialist. That's sort of my role in the military aircraft, is that I either operate the radar, I handle the payload, is I'm trying to help with these grassroots projects and find opportunities for people that don't have a great deal of bit of money, but do want to conduct science in order to fly in these commercial vehicles as well.
Um, so did you watch the Countdown Netflix documentary about Inspiration 4?
I have not yet, actually. It's been a very fraught month, if you will, with my work schedule and adjusting to it. I've been working long days, admittedly. I haven't seen as much Netflix as I would like.
I totally understand. I had gone to Cape Canaveral on the last moment expedition to watch the Inspiration 4 take off. So I was kind of cramming
Nice.
countdown before going there. But they do jet training, and I look forward to at some point getting your take on kind of what they were experiencing versus what you experienced the first time you went up in a fighter jet.
One of the, I will say, one of the good indicators for sort of the dynamics of high performance flight is getting that experience. Both whether you're there's something we said for getting in a high performance propeller driven aircraft, and I've done that as well, pulling in excess of 6 Gs or more, and having done that in an Air Force jet as well. It can be overwhelming if you're not prepared for it or haven't really thought about the experience of what it's going to do to you. It can be debilitating. Not recently, and I hope I can do it again soon. I went through the same centrifuge training that they did at the NASCAR facility in Philadelphia that operates an ex-Navy high performance centrifuge. And I got comfortable with it the first few times I rode it, not recognizing that I had to physically remember to breathe, if that makes sense, when you're doing like sustained plus 6 Gs, because I literally couldn't expand my lungs enough against the force of gravity to get a full lung full of air. And I kind of slipped a little bit while I did it, and it left me gasping a little bit because I could not breathe against that force.
Hmm.
And it really kind of woke me up. Now, unlike today's flight, on that Sorrel flight, they're experiencing positive G's in ascent and excess of Mach 3. So you're looking anywhere between 2 to 5 Gs, probably less on a vehicle designed for passengers, but you are getting quite a bit for that reentry mode in that 5 or 6 range, longer sustained. And that's where what the centrifuge training I did prepare for me for. And as somebody who remains relatively fit and exercises in regular, I got cocky for a second because I'm like, oh yeah, I've done this. How hard can it be? Oh yeah, that's right. Even in a snap roll in an airplane, that onset is fast, but you don't sustain it. In a reentry profile on a spacecraft, it's a sustained positive G's, and it hurts. It hurts if you're not prepared. So it's a lot to think about, like people going forward and taking part in space flight and realizing that it's not just an airplane ride. It's not even a roller coaster ride, like I hear some people say. Like this is going to be a extreme mental and physical experience in the positive, which is something to be prepared for.
That is interesting. I'm kind of curious in what your strategies are for dealing with the high Gs. Is it about not exhaling completely, or some type of posture that you do? How do you deal with it?
It's a bit of both. They do use an acronym called AGSM, or anti-G straining maneuver, which is realistically you're clenching your lower extremities in order to reduce the blood flow from escaping from your upper body. The ability to in that positive G environment where the blood is draining from the brain, you're getting the gray out and eventually blackout. The idea is by clenching the glutes and your upper thighs, you're retaining the fluids in your upper body and preventing your body from going unconscious because of lack of oxygen. And it's not that you can't breathe; it's that you're not. Blood is a fluid, and the fluid is going to pool away from the force of the gravity, and you're going to lose that oxygen processing simply because you can't get blood to your extremities or you can't get blood to your brain. In most cases, when you're flying a high performance aircraft, either pulling back before or snap rolling and such, the onset is fast, but you're not holding it for very long. This is something that's it takes some effort and it made me realize that I should probably do more squats. I should probably be better prepared for it. Now, these suborbital vehicles, they're still reaching great altitudes, but it's not nowhere near, say, like the force that a crew that might be returning from a lunar trajectory is going to experience. That's going to be a completely different animal.
If it's just a matter of kind of using your muscles to keep the blood from going into your lower extremities, I mean, has there been like work and study done on in terms of like having some type of pressure garment that like actually pushes on those parts of the body?
That is exactly why fighter pilots wear a lower body pressure suit in order to do that. At the rate of the onset of G's, the suit constricts the muscles in your lower body, helping retain the fluid. So you don't. Well, you're still going to actively do your countermeasures. You're still going to force your body, like you said, shallow breaths, constricting the muscles. The G suit is doing the hard work for you to allow you to maintain some cognizance and attention to your instrumentation, your altitude, or from your fighter jet, literally the maneuvers that you must take in order to avoid the enemy.
Now, I know that Inspiration 4 did centrifuge training, but as far as I know, the New Shepard participants don't. Have you heard anything about that?
I don't. One of the conflicts I have that we're still trying to come to this is, well, the FAA mandates a certain amount of training for spaceflight participants. It's very vague right now in the language as what that pertains to. I know that the folks who fly for Virgin Galactic all train at the same centrifuge facility. If you go there, you see their pictures on the wall just next to some of the volunteers for the nonprofit I work with, in the pictures next to them. But I haven't seen what Blue is doing for their training outside of the few clips that they've shown in their PR. They remain one of the most enigmatic kind of entities in this industry because they'll show you when they're done with something, but they don't show you much of the process in getting there. And I'm very curious to see what their training consists of, because so far no one's told me.
That's I'm sure we'll hear more about it as more participants go through it. And hopefully at some point, the whole Blue Origin experience, I mean, it only takes 10 minutes to go up and come down, and it's 100% reusable. And it seems like the most time consuming part would be repacking the parachute, probably.
Yeah.
I mean, at some point, I mean, why couldn't they fly that like dozens of times a day and bring the price down to like $10,000 a person or something?
I would like to believe the economy of scale is going to make that feasible, because one of the things I see with the researchers I'm working with is lots of great ideas where we have scientists and specialists that want to fly specific payloads, and in a lot of these cases they only need that few minutes of microgravity. They need sustained. To bomb a comet will let you experience it over and over, but you get that window. And if your experiment now has to be forced into a positive G and then a negative G, you're actually getting, a lot of these cases, you're getting negative data, whether that be an engineering experiment or a life sciences experiment. You're capturing little tiny windows of data that you could utilize. Whereas if somebody were to carry a similar payload right now onto Blue Origin's vehicle for the flight that they just flew, you have sustained like 3 to 4 minutes of microgravity. I know guys that would do anything for that, but their institutions can't pay the price right now to guide them a seat. And my hope is that the more often this happens, the ticket price comes down to a reasonable level for the average person.
Can you describe some of the experiments you could do in 3 or 4 minutes of free fall?
Yeah, so I have a good friend of mine that works fluid experiments, and he's been lucky. He's been working with the Canadians on their Von Comet aircraft, which I've flown on a few times and I hope to again. The idea that if his experiments are looking at these are, and we're talking about the simplest point of engineering, like how do these fluids, this viscosity, this material, this chemical makeup react to the lack of gravity or a percentage of Earth's gravity. You can fly some of these vehicles or even the Von Comet, say 0.38. if you can fly the right profile, you can simulate Martian gravity for a few seconds, which is amazing. But you're only getting it for a few seconds. The idea of being able to do a constrained experiment for a longer period would allow for more pure data, or at least more attention to the data, rather than having to mitigate the fact that you're going to get positive Earth gravity every few seconds as well. I know some of our life sciences experiments, particularly the level of scrutiny that goes into researching and using humans as test subjects, is another element. And again, some of that data is lost as soon as you put positive G's back on the person. But at the same time, I've also had as a test subject during the centrifuge and stuff, and I was wired up like the actors and the right stuff. I really did have like cords coming out of me and everything. It was great carrying around my little box of to sit there and record the data. And for that test, I got to experience that positive G's. I got to experience the centrifuge. Their effort to like, because it doesn't go anywhere. It's a giant heavy machine that's running on a lot on inertia once it spins to that point. To experience that sensation of onset of microgravity, from its rapid RPM, it slows, and your body kind of experiences that sudden lack of forward motion or lack of G's on the Z and Y axis. So it could simulate to a bit, and then it would spin up a slightly different angle, reorienting the cockpit, if you will, on the centrifuge to experience like a reentry profile. So it did what it could, and it gave a longer period. And I think that some of those experiments will be what's really, really neat about suborbital vehicles right now, at least in this sense, is like you said, once a vehicle's ready, it can fly again. And in theory, if you have more than a handful of vehicles constructed and ready to fly, you can continue this process over. You can wire up an astronaut right now with all the biometrics and biomedical experiments you want, put them in a Soyuz and fly them to the space station. But you're not going to gather that data until they re-enter sometime in the future later. You're gonna have the microgravity experience, and there's a ton of experiments on ISS specifically oriented at the human factors side. But you can't repeat it on the regular. Maybe every 6 months when you have another astronaut that goes up and replaces them on the station for expedition. But the idea that, in theory, if Blue had more than a handful of these vehicles available, you could test every week, every other day. It'd be amazing. That's just life sciences. That's not even talking about engineering and tech hardware demonstration. Some of the experiments I've seen some of the guys working on, we talk a little bit about fluid dynamics and fluids in the body. We know that after extended period of time on the space station, there are certain physiological effects of being in microgravity because your fluids shift. You're not experiencing gravity, you're getting that fluid shift back up in the upper body. There's an experiment that one of my friends is working on, essentially to build one of their little sleeping hovels that exists there, but basically have them wear sort of a, how would you put it, low grade order G-suit type device, but more designed like a sleeping bag, so they could clip into their little cubbies where they sleep, and would provide some positive pressure on their body in order to reduce some of that fluid shift. So the period of time and while they're in a rest, that their body isn't working against this fluid shift constantly, and they might be able to mitigate some of the long-term effects of microgravity. But that's just a tool. Clearly, if you can spin your spacecraft at 1 G, you can do away with all the problems of microgravity, but you created an engineering problem, and that's a whole nother ball. That's a whole nother game.
I sometimes feel a little bit more comfortable with engineering problems than people problems, but
that's true. That's true. And engineering problems don't nearly have the same level of scrutiny when you go against the board for the experimental approval.
That's true. So you mentioned that you are also involved in getting experiments from, I guess, research institutions and schools into orbit and onto these suborbital spacecraft. Can you talk a little bit more about that process and how do people participate in that?
Yeah, and I hope this doesn't come about across too much as a sales pitch, but for the last almost 10 years now, I've participated in a group that started right when this commercial industry started taking off. The idea was that you're going to have more space vehicles, you need to have more astronauts. And it started really with the idea that surely there are going to be more people flying in space. They need to be able to train for it and all that. And it sort of evolved from there. And it's gotten to this point where there are a lot of people out there that have really good ideas and want to make impacts in the space industry, but don't necessarily have the means to do so. What this sort of affiliated group of researchers is trying to do is find those people, advertise, and bring in resources and sort of bring a network together and find methods to help them develop their experiments through the various, they call them technology readiness levels. At least that's the term NASA likes to use. So once an experiment reaches a point where it's deemed safe, it's viable, and it has an application for its research, whether that fits into one of NASA's long-term programs or answers a question that a university or research institution is looking to determine, we hope to get these experiments to a point where they can be submitted as proposals for major grants with either CSA, ESA, or NASA, or one of these commercial companies. Because in the case of both Blue and Virgin, you can go directly to those companies and effectively purchase payload space so long as your experiment meets the engineering criteria in order to fly, as well as the safety. I know for the first few rocket tests before there were any additional people flying on Spaceship Two, NASA had purchased rack space on the vehicle in order to fly payloads that met their criteria under the Flight Opportunities Program. One of the things I'm trying to do, and hopefully we are getting closer to that, is not only take somebody's experiment, but the idea is to develop a researcher into this viable commercial payload specialist. Give them the training, provide them the resources, show them that. Now, I'm working through this as a nonprofit, and I can tell you that we don't have $250,000 to buy anybody's seat. That would solve a great deal of problems, moving the whole process forward a great deal. But so what we're working on is developing this validity within the scientific fields for each of their disciplines to be able to say, yes, this experiment has value to go forward. Now we can solicit from the various grant proposals or fundraising and things like that to move forward. We have there's some very smart people who work with this. I was talking about the gentleman that does fluids experiments. He actually did fly one of his experiments on the Dragon, and it was launched to the ISS. So there's some institutional knowledge and some processes here. And what used to be a very constrained field, particularly during the shuttle years, was that there was only one way to get your experiment to space, and that was to go through all these hoops and processes to be one of the lucky ones to get that little bit of space available on space shuttle. And hopefully, and 90% of the time, that was a passive experiment. That's the idea now with ISS, where you have a crew member living there. They can go to that payload rack, make that adjustment of the experiment, follow the directions of the developer, the researcher, relay that information back down to Earth, and continuously be able to do this is amazing. Changes everything. It's at least within the realm of science. And now we're looking at changing this up. Now vehicles are flying on the regular. NASA's talking about being able to put commercial payloads on these CLPS landers on the moon. It's not going to be this pie in the sky dream anymore. It's going to give access to these things to people that would never have been able to do this before. So it does seem a bit premature. When we started this group many years ago, I was just a young guy. I was flying in the Air Force. I'm like, that looks cool. I want to do that too. Now that I'm a little bit more intimately involved in it, I see the process and see the challenges of it. And it's not just trying to make astronauts. The idea is that there's value that can come from these things. I feel I constantly have to feel I'm defending the industry a bit because, yeah, a couple of rich people paid for aerospace projects to fly rich people to space. But $250,000 is not an unachievable dollar amount. The idea that we can now take this person that would never have the opportunity before to fly the research or themselves and go, I think we're that close. I think we're just about there.
Yeah, it's really funny. We're okay with rich people buying huge yachts or flying across the world in like super first class cabins and airplanes, and the sums of those add up to be quite a bit too. But nobody goes, wow, look at those people in first class. Why are why aren't they feeding the poor or something?
Yeah. I saw a really interesting comparison recently. I wish I could remember the exact numbers, but someone out there could probably find this. It was comparing the cost of a ticket to ride on either the Boeing or Martin flying boats, the Clipper boats in the 1930s. At the height of the Depression, both the uh, Martin and Boeing airplane companies produced these extravagant flying boats that would fly to the South Pacific and effectively take really affluent people to vacations in New Caledonia and Tahiti and Fiji, which nobody else would have had any access to during a global economic depression. And they talked about the price comparison to tickets at the time, which were several $100s, which expounded for inflation and modern times, tens of thousands of dollars. They were the equivalent of tens of thousands of dollars to fly on these vehicles to do that. And perhaps that would seem at the time, particularly during the Great Depression, as a very wasteful event. But they don't talk about how those very crews and airplanes and building ports in all those places allowed for air traffic to expand, allowed for navigational facilities to be developed. You could argue the defense side too. Those same pilots were able to train bomber and flying boat crews during World War II to fly the same routes later to help to win the war for the Allies. But at the same time, they took this idea of airplanes, which only in 1927 did a private citizen was able to fly across the ocean with Lindbergh. And that was effectively in a single seat, specially designed vehicle. There were a lot of comparisons and rightfully so because the funding with the Lindbergh Foundation, but when Spaceship One flew in 2004 with a single pilot to space and effectively a fiberglass aircraft, they were doing that Lindbergh flight. And just now we're getting to the point where, okay, you can sort of build a space vehicle and you can put a few rich people in it to buy seats and justify the cost of operating the vehicle. We're not quite at clipper ship stage, but we're getting to the point where, yeah, the affluent can buy a ticket on these new vehicles. In time, that ticket price, I 100% believe is going to be at a level to allow more people to fly. And if something positive can come from it, whether it be inspirational, be arts, or some sort of applied science, I'm all for it.
Yeah, it's really something to think about. And as you do think about that, 500 years may seem like an arbitrary number, and I suppose it is, but it's roughly the time between now and Christopher Columbus came over from
Right.
Europe, and I mean, pretty much everything that we consider to be the modern Americas was developed in the last 500 years. In terms of infrastructure, the roads and the plumbing and the houses and the systems of people that are currently here. When you look out in the future, where do you see humanity going in 500 years?
As a dyed-in-the-wool, old school, read all the good classic science fiction back as a kid kind of character, I'm still big on this idea that we're going to have a stronger, more robust, sustainable human presence in space. But as I get older, I also recognize things that I didn't anticipate. They're talking about little things that we just science fiction certainly anticipated, but not the preparation where we were seeing. We're talking about we've gone past revolution in miniaturizing electronics. Now we have these multifunctional networked cloud devices for data storage. I remember someone remarking that they thought it was interesting on Star Trek Next Generation, which came out in the 80s and through the 90s, kept showing the characters using like electronic pad devices to control data. I don't even have to do that anymore. Yeah, I have this stuff on the phone, but I don't keep all the data on my phone. It's in a networked cloud. Yes, it's run by a server farm somewhere, but it's not in the device anymore. We've already progressed past that level of science fiction. Now they're talking about gene editing and this elimination of some of these deficiencies we recognize in our own bodies. Like that's uh, that's that's science fiction as I remember reading the classics, and I think there's going to be this simultaneously shedding of some of the hangups and conflicts as a species or as a culture, while slowly embracing and stumbling through some of these technologies and the social impacts which we haven't even anticipated yet. The idea that we could change uh, the gene sequencing in an embryo and reduce genetic defects is amazing. Well, what does that mean? Does that mean that there'll be no defective births? Are we going to see uh, birth rates and those who survive through that period increased, or are we going to see a population explosion? Are we see population deficits as we embrace or react to changes in the climate or destruction of natural resources? Will technology be a solution to that, or is that aside from it? Are we going to be able to take all the science we've learned from this and be able to create a sustainable city on the moon or Mars? Time will tell, but I think that some of the groundwork is here, and I think that there's a lot of forward visionaries that are really going to find ways to describe what could happen still. And I'm still optimistic enough to think that those things are achievable, and some of it will happen in our lifetimes. By the way, I'm not a geneticist or in biosciences. I find it fascinating, but that's definitely not my field.
Yeah, I know it is kind of fascinating. I mean, one thing that's really changed over the past 100 years, I feel, is our ability to take expertise and knowledge and package it up in such a way that people can just use that result without actually understanding what's going on. Um, if you think about like the mechanical and electrical systems that were created, say before 1950, um, you it was open to inspection a lot more. They required a lot more maintenance, and so people had to actually understand how it worked, repair it, and there was a more intimate knowledge of those systems that I think led to more innovation and creativity and engineering. But what we can do now is essentially take expertise and put in black boxes, and we have no clue what happens inside that black box, but we just use it. And sometimes we use it blindly.
Yes.
And when it stops working, we have no clue. We just throw it away and get a new black box, right? Uh, and this leads, I think, to kind of maybe uh, doesn't diffuse knowledge as much, doesn't spark innovation as much, and kind of you have sort of this concept of smart tool, dumb user, or dumb tool, smart user. Those are pretty much the two choices you have. Are you going to put the smarts in the person that's using it, like say in a manual shift car? Or are you going to put the smarts in the car and have like this really transmission that knows when to shift to the next gear or down? And I just wonder if maybe we're kind of setting ourselves up for failure um, through this mechanism. I was just curious on what your take might be.
It definitely forces a reliance on the experts who are there. I had this conversation recently because I use, how should I put it, national assets using radar to track space systems as my day job. And surprisingly more so than the radars I use for targeting and avoiding weather and terrain and stuff in my airplane. Well, I understand I had to go through like theory and classes in order to operate those in the service on my airplane. There's only so much I can do in my airplane. I can't troubleshoot very much. I can't fix the electronics, and I certainly don't touch anything with that has raw voltage pouring out of it while I'm in flight for a safety issue. But there's only so much I can apply both in engineering and theory in order to operate this system. I know how to operate it, and I know how, in theory, how it operates, but I can't describe to you the technical aspects of it to the same extent that the engineers do. Now, in the occupation I'm doing now as a defense contractor, using these national assets, they're using more traditional radars. They actually have a team of engineers that's on staff to manipulate some of the functionalities of this, because they weren't designed with the operator in mind. And so if we encounter an issue, they actually have to go into the program. They actually have to go into the mechanics of the device to solve it. But again, it puts me in the dumb operator mode a little bit. Like, I know it's wrong, but I don't know how to fix that. I require the engineer and that industrial expertise. That person is the SME. That person is a subject matter expert. None of this operates without them. It's funny because when I'm flying on my airplane, I'm the SME for the radar as far as the crew is concerned. The pilots don't receive the same training. The engineer doesn't receive it. I have, but I only know how to make it work to an extent, or how it's working. I can tell you when something's wrong with it. The maintenance, the high school age maintainer that fixes the airplane might know a little bit more. And in some cases, a digitized system, rather than an old school radar dish, they're pulling silicone wafer cards out and inserting a new one, hoping to troubleshoot a problem. There's no mechanics for them to physically do that. But behind them is a back shop team that was trained by the engineers that can take that device away from the airplane, take it back to the bench, and actually work on it within a lab type setting in order to determine those things. So there's like this layer of subject matter experts and operators. And I recognize 100% I follow very well in that dumb operator. I don't know how this smartphone is programmed. I recognize it does require a programmer. I can tell you when something's wrong with it, but I don't know how to fix it.
I know. I'm not sure our relationship with this magic brick is any different than, somebody that had no concept of electronics. It's just like, we kind of understand how it was built, but like you said, I mean, something goes wrong that we can't do anything other than probably throw it away and get a new one. Like,
and for better or worse, the system is constructed to allow for that. If I crack this thing, I have to go get another one.
I'm still amazed at the phone fixer people at the mall, though. Their ability to take them apart and replace bits and pieces. It seems kind of.
I'm a big supporter of this idea, like this grassroots hands-on applications of technology stuff. Recently, the nonprofit I'm with, by the way, is called the Association of Spaceflight Professionals, the Confederation of International Researchers. But the idea of having a maker spaces and being able to give people that might otherwise not have access to do some of this tech development, whether it's like some basic Raspberry Pi Arduino coding or soldering or developing, because this is where some of these like these people who are going to make and break space flight in the future are going to get their start by getting this hands-on experiences. And I believe in that. I believe that those access. I look back and like I'm an adult male. I'm 41 years old, and I still had like one semester of shop in all my education going forward. So yeah, I understand basic woodworking. I understand some basic soldering or metallurgy, but I don't know how to do any of it. I've never had a venue to learn that. But there are people out there who have either embraced it or been in an environment to better experience those things, become this subject matter experts that are out there doing that, building these CubeSats, developing the code that applies them to make them functional. And I think that level of embracing this technological workspace we live in, for all intents and purposes, should be more available to people. I don't know how to program this, but I recognize that there are people that are, and by golly, we should be encouraging them to do that. Just as like the pushback against this proprietary repair element within particularly automotive and industrial equipment. The whole push against, I believe it was John Deere with the farmers, that they legally cannot repair their tractors under the current environment because the knowledge and the tools necessary to do it are held by the company, which allows for servicing contracts, You could argue that's a core element of finding a market within a capitalistic society, but I think it also reduces the effectiveness of being able to teach these skills and allow for people to have that habit. I want people to be able to program this. I want somebody to be able to pull up a wafer card and be like, yes, I know how to solder that into a device. We can program it to a basic function, because that same person can learn that skill and apply that to a CubeSat and be able to apply something for that those foundations of spaceflight as well.
Now, I I know I had scheduled this for 30 minutes, and I want to be respectful of your time. I feel like I've already gone
Sorry, if I
past.
went on rants, that's why. I'm
No,
sorry.
no, but it's absolutely okay. I just do you have more time? I
Yes,
didn't.
I do. Yeah.
Okay, awesome. Could you talk about the nonprofit that you do a little bit more? Is it something that people can sign up to be a member of, or
Yes, absolutely. And I say this without being too much of a salesman for it, because I'm on the executive team and I've been intimately involved in it. It's just one of dozens of organizations that has this like grassroots mentality. And I really, well, as much as I will sell the organization because I believe in its mission, I'm firmly pointing people in the direction of other organizations that might better fit their needs. Um, so the Association of Spaceflight Professionals is this organization designed with the idea of affiliating themselves and networking the access, knowledge, and tools available to develop human spaceflight payloads, and in time, the researchers and giving the tools to fly in the future as well. Uh, it's not like SEDS, one of the student groups necessarily, because we're not affiliated with the university level. One of our sister organizations, Teachers in Space, is specifically doing almost the same thing, but very oriented at educators who are focused on STEM outreach, but also providing tools to teach students at grade, middle, or high school level to work on payloads. And they actually attempted to launch one recently at that, but unfortunately was lost in that accident in Alaska last month. But within the organization, and I should point out, I'm not a founder. The founder is a very incredibly intelligent individual named Brian Sherrow, Dr. Brian Sherrow now, who is working at the USGS. And I believe at least once, maybe twice, was made it within the last 100 applicants in the astronaut class for NASA. Very incredible individual. And he envisioned this idea a decade ago with the onset of all these vehicles, even well before any of them were flying. The idea that the average scientist with the right applied research can find a venue to take their experiments to space. And what do we need to do to find these things? How can we define something for an industry that doesn't exist yet? And how accepting is an industry going to be of something that might be perceived laughable and would have been laughable 20 years ago? But after saying even things like today's flight, like it's just that much closer to being a reality that space is available for everyone. It's not there yet. I certainly can tell you that I don't make enough money to go buy a seat on either of the vehicles that are flying suborbital profiles. But the hope would be that if somebody in this organization or one of our sister organizations wanted to develop a payload, maybe didn't have the resources, didn't have the access to a lab at university or a makerspace or something like that, but could be provided or pointed in the right direction, that there are people within this organization or some of our partner organizations that can be pointed and given and shaped in the right way in order to make them a viable candidate for some of these things in the future. And by virtue of being a nonprofit, we're not building hardware. We're not looking for proprietary elements of it. We are not buying anybody's intellectual property. The idea is that these are tools in order to enable the future to go forward. By making it a nonprofit allows us to be able to stand on a hill and say, look, this is for the betterment of everybody. If your payload flies, it's good for everyone. If you want to utilize one of our better trained or equipped experts in some of this stuff, we have some incredibly talented people that came to this organization with the intent to fly, um, maybe they can be used. Maybe a research institution can bring them, push them forward with their payload. And I think that's we've just quite we're just quite at that point where recently a university in Canada wanted to buy. They want to fly an experiment on a Vomicomet, the Canadian Vomicomet specifically, out of NRC Ottawa, and they came to our organization and partnered with us to fly one of our members to carry the experiment. Not only are we giving this per individual an opportunity to go experience an aspect of spaceflight, go experience that microgravity, but they're going to carry this experiment tool and learn this a bit as the expert in the spaceflight in order to do so. And it satisfies the university's needs, satisfies their ambitions, and it meets the mission of our organization as well. Being a downside of being a nonprofit, seeking out the funding to make this possible, to make sure that this individual had a seat, was a challenge, but it was accomplished. And we can rest safely and say that the model kind of works. It's just going to take some time. Just as airlines and some of these smaller, particularly flight research projects out there, appeal to the industry, look for experts. Hey, would you like to come do this? Or hey, we're paying somebody with this that needs this level of expertise to go forward. The hope is that an organization like ours will be able to point and be like, we have somebody available, or point to the sister organization and be like, these folks right here have the tools available to meet those needs. And we all benefit from that. We do it internationally. That's about one of the great things too. We have footprints on it, every continent except Antarctica. Our hope is to slowly build up a base like this, a network of with the institutions in Europe, and in time with Asia. Obviously, there are issues with ITAR, but the best parts about it is we're not while we might facilitate the development of space hardware, we're certainly not putting anything in a position where it'd be weaponized, and we're not doing anything with propulsion. There are plenty of people building rockets. That's incredible. It's awesome. It's a great thing that there are so many rockets available. The organization I'm with is looking for payloads, and specifically space science payloads as experiments, not necessarily something going forward for profit, but if a company is looking to develop something that with a profitable end and selling that product, an organization like this would be able to work that as too. Many years ago, we flew with 0G, and there was a small microbrewery company that wanted to do beer in space. That was the title of their project, and we flew their experiment on the 0G spacecraft. They didn't have experts in it. They had brewers. They had guys who could run tanks and put yeast in tanks and sell beer. What they didn't have is a pool of people that could fly microgravity flights and conduct that experiment and be able to demonstrate that, yes, their machine works and you can feasibly develop the process for brewing beer in microgravity. The carbonization element of selling it on this, back at 0G is a whole nother animal. NASA's had that same problem with putting soda on the space station because the gases will separate from the fluid, but that's a whole nother problem. But this model can work. It just, we're at a stage of like many startups. Nobody knows we're really there yet. So we're trying to get to that point. But at the same time, there are other organizations doing similar things. We recognize that, and we're not seeking to usurp or replace anything, because this is more of a public service than a company. Sorry if that's a long-winded answer, but it's something I believe in, and it's our hope is to get to a point where one of our candidates or one of their experiments is viable enough that either it goes through one of the grant processes, one of the major space agencies, or with one of these companies directly, and that someone with our patch flies on Blue Origin next time or Virgin Galactic.
That sounds really awesome. I remember when the space shuttle was flying, being a mission specialist was a lot more achievable than it is now.
And I recognize that in the challenges of some of my peers that have competed in for the NASA astronaut selection. If you look at the breakdown of the recent candidates in the recent classes, there are a lot of test pilots, because they're selected to be the ones that are going to operate this new fleet of vehicles, these commercial crew vehicles, operate Orion in its early stages. As much as I hate to say it, there's not as much need for planetary scientists or specialists in some of these other natural science fields. There will be one day, but there isn't today. But that doesn't mean that we can't begin developing those people now and giving those opportunities. They may not be NASA astronauts, but we will do our best. I think in the industry has this opportunity now available that maybe they're not NASA mission specialists, but we can probably find a way to make them a commercial mission specialist. They just might
I,
not get that nice federal paycheck.
I think they're motivated by the view and the experience and the
Aren't we all?
yeah, it's like you know, I've been trying to learn to fly a Cessna 172, and you know the flight instructor only gets paid $40 an hour, but the money is just enough to feed him, right? What he really
Right.
wants is the hours that he's building towards being eligible for going to the airlines or something.
Absolutely.
So actually, money is really a poor motivator, you know. It's all the other stuff.
Well, I understand completely, and I recognize that there's no Buck Rogers without Bucks. Got to have the money there to make it happen. But I find that nobody that I've worked with in this nonprofit is doing it for the money. We do come around occasionally and be like, you know, we become a bigger organization. Surely we'll have to pay somebody on the staff in order to do some of these administrative tasks. But we're not there yet, so it's all volunteer basis. Nobody's doing this to get rich. Everybody's doing it to try to see it go forward. If we don't make the machine work, we're not going to get those people in space. So we rely on the enthusiasm and interest of people who want to take part in this. And surprisingly enough, there are a lot of people out there that are willing to do that.
I definitely, I unfortunately though, spending the bucks doesn't guarantee Buck Rogers either.
No,
I think whenever you look at some of the traditional space contractors and some of the new startups, you find that a dollar goes a lot differently.
it does. Uh, I can safely say that I have avoided, for better or worse, being too intimately involved in federal contracting. Although I've been around it, I did fly a operational test evaluation for new avionics for the Air Force at one point, and politely excused myself from the budgetary meetings because I didn't even want that on my mind while I was out flying and testing the equipment. That's a program management concern. Wasn't as much of my concern as somebody that was doing the flying portion. Now that I'm on this other side, this nonprofit, I do see costs being a factor, particularly development costs. Recently, we've partnered with a major university in Canada that's got a lab that wants to do payload development. I can safely say that ASP, Association of Spaceflight Professionals, as a nonprofit, more than happy to take on and help them, but we can't give them any money. That's going to have to come from other sources. And the motivation obviously isn't on their part to get rich. Nobody's going to get rich spending money on space hardware, particularly one-off type experiment. They're in it for the gold. They're in for the experience. And my hope is that we can help them develop these to a point where it gets to fly. We're starting small. We'll start with vomit comets. We'll start with microgravity flights. We'll work our way up. It'd be amazing, you know, if it's like a CubeSat sized unit, if we can get something on ISS, or a commercial station, or commercial free flyer, or Blue Origin. Who knows?
It sounds wonderful. I had a few other standard questions I want to run by you. If it was safe and affordable, would you go to space?
Absolutely.
And how far would you go? Just to suborbital, orbital flight to the moon and back, or would you maybe immigrate to Mars?
That's an excellent question, and it's interesting you asked because I did take part in a 4-month Mars experiment on behalf of NASA during one of their analog missions at the High Seas facility in Hawaii when that was operated under a grant program for NASA the Human Research Program out of Johnson. And one of the best parts about that experience was getting to be like an astronaut. I had to go through medical and psychological testing. I had to meet all these criteria to do this. And then I got to go experience what it's like to be a pioneer for all intents and purposes, a modern pioneer, no covered wagons, but looking at the process of spacesuits, and not just spacesuits. Oh, we got to worry about pressurization. No, we've got to worry about how to care and repair a spacesuit. We got to worry about decon. We've got to worry about all those elements. And the more I learned, every aspect of life became more complicated with layers of what ifs. What if this? Well, what about that? It made me realize that I think it's within the means to put people on the surface of Mars. I don't think that the average person, even the average spaceflight enthusiast, if you will, understands the complexities of mitigating the fact that even the worst day in Antarctica is more survivable than the best day on Mars, because at least there's a link and resources that you can ask. Nobody's coming to you from Mars. There's no way to generate anything on your own. You're completely at the mercy of what you've brought with you. Now, for in situ resource utilization and some of the tools, the idea of being able to 3D print things and develop some of these things in the future, I'm 100% behind that. Would I do that? I hope that I was so intimately involved to be aware of the development and be in the process, because just shooting people at that planet and hoping they make it is just not feasible. It's much deeper. Would I go on a suborbital space flight tomorrow? I'd like to do some more sit-ups and make sure that I could handle the G's better, but extended stay, something like Inspiration 4, a few days in orbit or a couple weeks in orbit, provided I was trained properly, I have no problem doing something like that. But I'm a true believer and I'm into this stuff.
That's awesome. And I think back to our conversation about black boxes and Mars and the difficulties, and you can't bring anything there. I mean, I think the challenge with going to Mars is you want to have the absolutely simplest systems that you need, like no black boxes. Everybody understands all those systems in and out. They know how to manipulate them and repair them and troubleshoot them and kind of be able to adapt them as the situation changes.
One of the things that people are surprised I talk about, like just the challenges that I experienced while I did that. We didn't have flush toilets, even though we were doing this experiment effectively in this mock habitat here in the States. What we had was a biological toilet. And well, this is one of those human factors kind of questions. Like, they wanted to have something that was so simple, they were required next to zero crew interaction. So what they had was this device that did have a motor and had a fan in order to maintain a bacteria culture within like basically a compost type bin. So if you add matter to it, you could keep it at an equilibrium. If the tank containing the mass, if you will, was at the precise temperature and had the precise airflow, not only did it create a bit of a vacuum to allow for matter to enter without exiting, it allowed for the culture to survive indefinitely. And so long as you didn't change those parameters and you had a self-perpetuating bacteria culture, you could continue adding mass to it for the foreseeable future. The downside, of course, is that there are outside factors. One of the things we experienced, we did this on about 9,000 feet on the slope of Mauna Loa volcano in Hawaii, was as Antarctic as the appearance of the ground was, as Martian as it felt to be isolated. You're still on a tropical island that experiences tropical depressions and storms. And when we had storms that would settle over the island for days, our solar power would eventually diminish, and our backup generators feeding off a hydrogen fuel cell would slowly tick away. And one day we reached the maximum potential, what you could lose as far as power available. And one of those cultures got too cold and it died. which meant that after a couple days of adding mass to the culture, became aware that they were no longer eating the mass,
Yeah.
and now we had a problem. Now we had a significant problem. In theory, you could develop a much more integrated device, and I would love to believe that anytime NASA envisions building a habitat on the surface of Mars, that you would have fail-safes amongst fail-safes and redundancy in this. Maybe you could do a device like that, build something that's so simple that you don't have to interact with it, but you'd still want a system to tell you that something is wrong. We didn't have a system to tell us what was wrong. We were just sort of, oh, that's a problem. Now we need to do something about that. But what was simple, and I love telling that joke when I talk to classes about that, because that's one of the first questions. How did you go to the bathroom in space? I'm like, no, let me tell you about our little bacteria buddies and how this worked. The next problem was in this simulation, how do I not make this life-threatening? Because realistically, even not life-threatening, even just living in a somewhat closed environment in this smog habitat, I now have a biological waste problem that could get me sick. It could contaminate foods. It could contaminate the people here. So we had to devise systems to extricate that mass, take it away from the habitat. It was a whole thing. And that's simple enough. I could go out in my fake spacesuit, move this mass in a contained biohazard box away from the habitat and be like, mission accomplished. Be a hell of a lot harder for a dude in an EVA suit with his other buddy in EVA suit to manage to do all that, not create a conflict, now develop an EVA profile, a mission effectively, like go out in your self-contained spacesuit in order to accomplish the same task. We recognize that we had it very easy, but one of the goals of this program was for NASA to be like, what challenges will you face and how will you resolve them? Because of the distance that Mars would be from Earth. They had in place the same comms delay that you would have on Mars. So roughly 35 million miles away, 20 plus, give or take, minutes of radio comm for that message to transfer out and go back and then get your reply. And in many cases, we would resolve problems, we would identify problems, relay it to our simulated mission control, and find a solution before they could advise us to something, which is all about that autonomy. And it's also something that none of the astronauts that are flying today in NASA have anywhere near that level of autonomy. I briefly worked as a flight controller over here at Marshall Space Center for the space station, and their lives are under so much scrutiny and minute-to-minute planning that you can sense sometimes the amount of frustration and burden it creates for the crew on the space station, which they don't have to worry about a number of the things you'd have to have with a free flying vehicle, because other than a regular boost and resupply, like the station is there, you have systems monitoring it, and you've got operation centers around the world supporting the various functions. But on Mars, you're not even going to get the signal for a fault code for 20 minutes or more. We were tasked with developing a level of autonomy away from people that were trained with this mission control model. And you could sense their frustration because they wanted instantaneous answers. They wanted the crew to respond. Like, what do you mean you guys are having an emergency? Why didn't you? It's going to take 20 minutes for you to get that message to us. So by the time we have responded, we should have a resolution because we have to. We wore mock EVA suits that were developed by University of Maryland as a test. Could they develop a surface EVA suit to mimic the same kind of functions as you would based on the Apollo lunar EVA suits? With the idea that, can we build it lighter? Can we build it stronger? Can we use modern materials and all this? But still, in order to simulate that element on Earth, they made it heavier in order to seem like the mass that would be required to operate that in 38% gravity, this EVA suit weighed an extra 50 pounds. So every time we had to plan or to go out and simulate an EVA, it was a physical burden.
Hmm.
Now we wouldn't experience that same weight on Mars if we'd taken a similar suit to Mars, but we would experience the same level of physical uh, impacts to endurance and to health and to functionality and dexterity. All those elements were there because they made it harder than it needed to be here. You would never have to build a suit that heavy here. You're going to try to create a suit to take yourself outdoors of a building, but they made it that way. We joked it was for a while it was the best weight loss program we ever had because you'd lose 4 to 5 pounds every time you went outside wearing this suit, even with liquid cooling garments, fans, and thermal protection inside, because you simply were exerting that much wearing it. So every little thing compounded, and I hope that the people that have the right voices, again, talking about the poets and artists that can say this perhaps better than the engineers can, is that Mars is an incredible vision. Human spaceflight is an incredible vision, but it is a much greater challenge than they portray in the films. Much greater challenge than they portray in sound bites and Facebook articles and things like that.
That's for sure. So what do you think about us going back to the moon? Is it something that you're excited about, or?
I'm 100% excited about it, and I believe that if it's done in a sustainable manner, and while I don't believe that perhaps the exploration roadmap technologies are sustainable in themselves with the federal dollar the way they are, or the vehicles and programs they've selected, I believe that their willingness to partner and if you will, share the load with the commercial partners that they've selected, even down to these CLIPS landers. The idea that yes, it's a NASA-sponsored mission, but that an astrobotic company out of Pittsburgh can send a commercial lander to the moon with payloads that they've selected amongst their vendors in order to test technologies. That's a baby step toward having a lunar McMurdo. Every little piece of technology you can demonstrate that's effective, every entity that can demonstrate that it's accessible makes all that just the more possible. The headlines are going to go to the landers. The headlines are going to go to the crewed systems, but it's going to be these other little elements that create the foundation of the things going forward. I'm 100% behind the idea of having a permanent human presence on the moon. It's 4 days away. It is right there. It takes me longer to drive across the country in my truck than it does to go to the moon. But I never have to worry about bringing my own oxygen, so I realize that that's not a very fair comparison. But it's right there. And if we can demonstrate access to the moon repeatedly, positive access, another launch, another crew return, another launch crew return, then the idea of having a base there is not this wild vision. That makes it possible.
That is, I mean, it's going to be transformational, I think, whenever people can look up with maybe a telescope and actually see evidence of human activity on the moon. That will make it a lot more real for a lot of people.
I think you're right. I think the first time that you can go outside and look and be like, oh, someone left the lights on up there. It'll be a nice day.
Well, I know we talked about a whole bunch of topics, and that was pretty much all the questions I had, but did you have any questions for me or anything else you wanted to talk about?
Not specifically. I'm curious who all you're interviewing and where you're going. What would you like to do with all the information you receive from people?
That's a really good question. My answers aren't satisfactory even to myself, so I think it might be too much for them to be satisfactory to you too. But if you remember back in 2019, Doug Laverio was hired by NASA to head up the Human Exploration and Operations Directorate.
Okay.
And he had a lapel pin where he was counting down the days to the end of 2024 because he was laser focused on boots on the moon by 2024. And he started going around NASA highlighting like a NASA person of the day as contributing to our efforts to get to the moon. And so in December 2019, whenever he started that, I thought I would go and interview regular everyday people like at Starbucks, on the streets, at the airports. And I did that from December till the COVID lockdowns in mid-March. And then I had to kind of be a little bit more flexible. And I actually wanted to interview all non-space people,
Okay.
just to kind of capture that perspective. But I kind of see this as a time capsule for future generations to look back on at that moment right before where space seemed possible, but it hadn't quite happened yet,
Right.
because I feel like that moment's going to pass away really quickly, which I'm really excited about. Let's make it pass away quickly. But it would have been pretty lame for it to be all non-space people going, I have no clue we're going to the moon. Not sure why we're doing that. That looking back on time, people be like, nobody was interested. I'm not even sure why they went. Look at all that.
Yeah.
So, yeah.
No, that's a really interesting like sociological perspective to take on this stuff. Like to recognize that this is that moment in transition, or should be that moment in transition. And what is the impact of that? What is the cultural response? What is the wake? What are the ripples in the water for that moment in time? That's really interesting. I like that.
And
I also agree with you too. It's far easier to find people who are unaware of things that are taking place in space, or have a skewed view of it because of the way the message is portrayed or populated. I received paychecks from NASA, and I had people that I work with in the service were convinced that NASA had been abolished and shut down. Like, I literally bought you a beer with money that I just got paid from this organizations. Where's it coming from? Because they had such a limited viewpoint and taking this microcosm of input and sound bites they'd received from the media without delving any deeper. And I think that could be argued for 1,000 things within popular sphere and what comes across these devices. Without reading beyond the headline, you'll never know. But at the same time, I because of the, and I'll throw NASA on the bus again. I love what they're doing. If you read through things, you can see the intent. But man, sometimes it's hard to gather. Like, hey, we did a PR press. We're demonstrating this Artemis tech. It's one more component for the rocket stack. I'm like, most people are like, what are you talking about, moon rocket? What do you? I thought Elon builds rockets now. Like, what does this have to do with anything? There's no context. There's a soundbite or there's a press release, but there's no context for the picture. And I am a nuts and bolts guy. I'm a tech guy. I'm an aviator, and and now I'm working satellite systems for the Department of Defense. But I recognize that it's a human story. Without context, it's nothing. A book on engineering is nothing but figures unless you put it in context of what that technology is for, what it does. And if we can't tell people why people should go to the moon, or why people deserve to receive the benefits of doing something like that, they're not going to be in support of it in any way, shape, or form. I think people will be shocked. I think the average person would be shocked to know that there's multiple international stations, if you will, on the Antarctic surface, and people operate there all year round, even when it's really, really inhospitable to do so. Because I feel that that's the model that will take place with the moon. It'll be a Concordia station or a McMurdo-style station, and it'll be periodic resupply missions or bringing a new researcher to it. And it'll be some poor government-funded researcher living in a habitat module, drinking instant coffee and wondering what he's doing with their life as they prepare their next proposal. But their presence alone makes it more possible for the next person to be there. So I'm down with it. I'm into it. But even I can stand on my pulpit here all day and say this is something that should happen. But even I have a hard time telling people, the average person, why it should happen.
Yeah, I think it's a matter of faith, a matter of belief, of you know, fundamental values that have nothing below them supporting them. It's like either you have the vision of humanity branching out into the rest of the universe, or you don't. And it's hard to justify that in any reasonable way, given the context of our daily lives and the time scales that we operate on, and our current relation to nature. I mean, the sun going out in a billion years or two, people are like, well, I'm worried about war with China over Taiwan,
Yeah.
next 3 years. That might be a little more immediate crisis.
One of the arguments, and I try to edit myself very carefully, saying like, people are like, why are you coming to the defense of these billionaires building spacecraft? And I've tried going, I'm not. What I want to do is be able to take my researcher friend over there and her experiment and make sure that she flies that experiment on that vehicle, because that vehicle is there now to see the benefit. One of the experiments that my organization is facilitating, fostering, if you will, is this a mechanical device being developed by a university in Canada for auto transfusion of blood, which those devices existed, but no one's ever tested them in microgravity. If somebody were to require a blood transfusion, crew to crew, on a 6-month free trajectory to Mars, it'd be really nice to make sure that that technology is available and in the simplest form possible, applied science. Now, that's a very specific tool for very specific what if. But the idea of being able to have a device that could aid a blood transfusion, no matter what orientation it is, regardless of interior or exterior pressure, and won't cavitate, would be a wonderful tool for terrestrial rescues. If a rescue team needed to conduct some sort of transfusion in an inhospitable or dangerous environment. There's applied scientists. Maybe that's very esoteric and outside the realm of the average person. But I believe that that little piece, that's not only is this going to enable that much more feasibility for human spaceflight, but it's something I can turn around and point out to people that, why did we do this? Because someday somebody is going to roll their car off a mountain and require a blood transfusion somewhere, and there's going to be a rescue crew at the bottom of that mountain that can conduct that, because we tested this device and it works.
Yeah, I know that would definitely be helpful. I mean, just re-examining our assumptions, right? And kind of looking at things from a first principle perspective opens up a whole new way of approaching these problems that we just accept. I mean, just consider the rooftops on our houses. We've kind of gotten, kind of stuck on this little pointy thing because everybody has them. But maybe that's not the best way to have a rooftop. But you go and start putting structures on Mars and you build it a different way, and then people are like, oh, why'd you do that? That's interesting. I want a Martian house. Suddenly
Right.
this fundamental thing changes. Well, very good. Well, thank you so much, Casey, for all your time.
Absolutely.
And
I appreciate you having me.
it sounds like the nonprofit is doing wonderful work. I'd love to find out more.
Absolutely. And I hope I didn't run off on tangents too far here. I admit I'm a true believer. I'm wearing my Star Trek shirt. I want a Star Trek future. I want to be there. I recognize I'm not going to be galloping around the galaxy in a warp class vessel. So let me work on what I can work on from here now.
Who would have thought you'd be talking to people around the world in a couple of seconds with video and audio?
Sure.
It just takes that one person, that insight, and suddenly the impossible becomes every day.
Absolutely.
Okay, well, take care. Talk to you later.
Thank you. Appreciate it.